Welcome back to the Deep Dive, where we turn a stack of sources into crystal clear insight. Today, we are taking a really fascinating and super practical look at the world of large language models. Specifically, what happens the moment they leave the safety of the lab and hit the real world. So you've spent weeks, maybe months, perfecting your model. You've run all the tests. You've checked for safety, for relevance. But here's the pivot point we found in the material. Once that LLM is deployed, its behavior is, well, it's completely redefined.
It really is. It
Yeah.
stops being about its internal weights or those perfect, clean test sets. Now it's about real users, unexpected inputs, strange edge cases. The whole rule book just gets thrown out.
Right. And that chaos forces a pretty fundamental shift in thinking for the engineering teams.
Absolutely. The question that dominated development, is the model any good? That question is it's instantly replaced by something far more urgent. The new question is, what is actually happening inside my system right now?
And the key to answering that is observability. The sources we looked at have this great image of observability acting like a lighthouse. A user sends a prompt, it hits the LLM, they get a response, but that whole process is often a total black box.
And observability is the light that shines through it. It gives you sight lines into every component, every decision, every single delay.
So it's about catching the system in the act.
Exactly. When the training wheels are off,
Huh.
you have to track the real-world inputs, the final outputs, which components fired, how long each step took, and maybe most critically, where things start to silently break or drift or just get too expensive. That visibility is everything.
So our mission today for you is twofold. First, we're going to really crystallize the difference between testing before deployment evaluation and tracking after, which is observability.
And second, we'll see how an open-source tool, OPIK, makes all of this practical, how it gives you that instant visibility into everything from token costs to, weird failure cases.
Okay, let's start there with that often confused pairing. Evaluation versus observability. They both use metrics, they both judge performance, but our sources show they play totally distinct complementary roles.
Yeah, let's unpack that. We'll start with evaluation. Think of evaluation as like a rigorous inspection done under perfect controlled conditions. Its whole purpose is to measure how well the system performs on a defined set of tasks.
And that means using curated data sets, running specific benchmarks. You're doing this before deployment. You're assessing these static qualities, right? Is it factually correct? Is it safe? Is it relevant?
Precisely. You're establishing the theoretical best-case performance. You're setting the baseline.
Okay, so then how does observability contrast with that?
Observability is focused purely on the live operating reality. It captures the messy, unpredictable production environment. We're talking real user inputs, that one person who tries to paste an entire PDF into the prompt box.
Right.
We're talking about the actual model outputs, latency, token consumption, and especially for RA systems, any context that was retrieved from a database.
So, if I can try an analogy, is evaluation the promise and observability the messy reality?
It is a perfect way to put it. Think of it like this. Evaluation tells you that your brand new car can go 0 to 60 in 4 seconds on a perfect track.
Okay.
It tells you the engine should be efficient. Observability, on the other hand, tells you that when you drove to work this morning, it actually took 7 seconds because you hit traffic.
And the engine overheated a bit.
Exactly, because you were using lower-grade fuel. It's focused on the failure modes you never saw coming.
Ah, I see. So its goal is to detect those real-world issues as they happen.
As they happen. Regressions, performance bottlenecks, explicit failures, like an external API suddenly slowing down, or even just sudden shifts in user behavior that might lead to unexpected costs.
So the key takeaway for you, the listener, is what then?
It's this. Evaluation establishes the ideal, the baseline, the expectation of quality. Observability ensures the system continues to meet that standard out in the real world. You need both.
Right. Without evaluation, you don't know what good is.
And without observability, a model that tested perfectly can silently and expensively fail you in the wild.
That makes the distinction crystal clear. Now let's shift from the theory to the practical. How do developers actually get this visibility? The framework highlighted in the sources is OPIK, which is a popular open source solution.
Right. OPIK is designed specifically for this. It gives you the tracing and monitoring tools for your LLM apps. It's a really lightweight way to capture the inputs, the outputs, and those full step-by-step execution traces we need.
And it's not just for LLMs.
Not at all, and that's key. It provides a unified view, tracking everything from a simple Python function all the way up to a really complex multi-step agent.
Okay, so to understand the mechanism, the sources start with a really basic function. I'm talking def my function x in.return x plus 1 to an advanced listener that looks almost patronizingly simple. Why track something like that?
That's a great question, because the power isn't in tracking the addition, it's in tracking the component. The key implementation detail from OPIK is this thing called the @track decorator. You just wrap any function with @track, and OPIK automatically logs its execution.
So why that simple function?
Because in a real-world LLM agent, that my function could be step 3 of 15. It might be a database lookup or a call to a payment API. So if your complex agent suddenly fails or slows down, the trace from OPIK shows you precisely. Step 3, the my function component, took 90% of the total time.
So it turns this tangled mess into a simple, traceable chain.
Exactly. It's about building fundamental visibility into each individual building block.
And when you look at the dashboard output from tracking just that simple function, it's remarkably clean. Every time you run it, it's logged. Input x1 gives you output 2. Run it 4 more times, and you see all 4 calls, each with its own execution duration.
Right, that's the foundation. You get monitoring and debugging for any piece of your system. And you don't have to write hundreds of lines of boilerplate logging code to do it. It just seamlessly scales that simplicity up.
Okay, let's move to the main event, because the real value here is tracking those interactions with external commercial LLM APIs. That's where you have to manage tokens, latency, and critically cost.
Yeah, for commercial providers like OpenAI, OPIK has really deep integrations. The core step is using a function called track-opini. You just instantiate your OpenAI client, wrap it with this function, and that's it. From that point on, every single API call is automatically monitored.
The source material used a particularly rich example for this, a multimodal prompt.
Oh, yeah.
The input wasn't just text. It was a prompt, what's in this image? But it was combined with an actual image URL. They used GPT-4a-mini.
And this is where the production value really shines. The trace you get back is so much more than just input-output. When you open that trace in the dashboard, you see the input, the text, and the rendered image right there. But then you get the crucial production metrics.
I remember seeing those data points. What stood out to you as the most impactful detail logged for that single call?
For me, it's a combination of performance and finance. That's the killer feature. For that one call, which took about 4.7 seconds, OPIK logged the precise duration, the total tokens used, 2,614 tokens.
Okay.
And the exact cost incurred for that single interaction down to 4 decimal places,
Yeah.
0.000210990s.
That ability to track costs down to a fraction of a penny, how does that actually change how teams plan for their LLM usage?
It changes everything. I mean, before this, finance teams would estimate costs based on bulk usage.
Yeah.
I guess. Now, engineering teams have surgical precision. You can see immediately if a new prompt template or a different model causes a cost spike.
So you can set up alerts.
You can set up alerts. Exactly. If a user's prompt goes over a certain token count, you flag it instantly. You move from abstract budgeting to continuous, granular financial monitoring.
So if I see that one prompt variation is costing me 50% more per query, I know exactly which part of my system to optimize.
Exactly that. You can pinpoint the economic impact of every single design choice you make.
That's incredible for those high-cost commercial APIs.
Yeah.
But let's bring it back to the development environment. What if a listener is running open source models locally, using something like a llama? Are we blind there?
You'd think so, but no. And that's the beauty of using a unified framework. The process is almost identical.
So you still use the same track-opini function.
You do. You just configure the client to point locally.
And the trick, according to the sources, is just setting the bezier to point to your local server, like http://localhost.11434v1.
Correct. You send a simple prompt to your local model. The example used Llama 3.2.1b. You wrap that locally configured client, and OPIK handles the trace just the same.
But why bother tracking a fast local model if production is going to be a big, expensive commercial one? What's the practical advantage?
There are a few crucial advantages. First, latency testing. Local models are usually faster, sure, but OPIK still logs that precise duration. You can benchmark your iteration speed. Second, and this is maybe more important, is development parity. By tracking it locally, you ensure the complex logic you're building is observable in the exact same format as your cloud deployment.
So it makes migration and debugging way easier.
Infinitely simpler. You can iterate fast and cheap on your machine, but you log everything as if you were running in production.
So it gives you a consolidated view, a single panel where I can see the 4.7-second multimodal cloud call right next to the 0.2-second local Llama 3 experiment.
That's the synthesis right there. OPIK successfully logs all these diverse environments, giving you that unified view of system performance. Whether it's a simple function, an expensive API, or a cheap local experiment, it's all measured and traceable. That's what really accelerates debugging.
Well, that brings our deep dive to a close. We defined observability, clarifying how it's the essential partner to evaluation. One sets the baseline expectations.
And the other ensures those expectations actually hold up under the chaos of real-world production.
And we saw exactly how a tool like OPIK provides that instant, seamless visibility.
Right. It takes a black box of a deployed LLM with all its multimodal inputs and multi-step agents and just transforms it into a transparent, measurable system. That transparency is the engine for catching performance drift, silent regressions, and unexpected bills.
So if evaluation is the safety certification for your LLM, then observability is the continuous flight recorder that catches the real story. And that leaves us with a final thought for you to consider. What crucial performance and cost metrics are you missing right now that could be revealing a silent regression in your most critical production workflow? That's something worth thinking about. Thanks for diving deep with us. We'll catch you on the next one.